So good afternoon, student. In this video, I will be discussing benzene, an aromatic compound. It is the parent aromatic compound. So the formula of benzene is C6S6. C6S6. These hydrocarbons, so this comes under aromatic hydrocarbon. Aromatic hydrocarbon. So benzene is regarded as the parent aromatic compound. So aromatic hydrocarbons are also known as arenes. They are also known as arenes. Now let us look at the structure of benzene. It has a cyclic structure with alternate double bond with 6 hydrogen. This is the actual structure of benzene with 12 sigma bonds, 3 pi bonds, and the formula is C6S6. So the ratio of sigma to pi is 12 upon 3, that is 4:1. So both this question has been asked. What is the total number of sigma bond? What is the ratio of sigma to pi? So note down.
Noted, sir.
Now the word aromatic comes from the word aroma. Aroma means pleasant smell. Pleasant smelling or pleasant smell. So aromatic means pleasant smelling compound. Now keep in mind that benzene is a highly unsaturated ring system. It has conjugated double bond. Conjugated double bond means alternate double bond, single bond, like double bond, single bond, double bond, single bond, double bond, single. This is called conjugated double bonded system. So remember the trick CPCH, cyclic, planar, conjugated, Huckel's rule of 4n plus pi. So this makes benzene aromatic compound. So I will discuss aromaticity in detail. So cyclic, planar, conjugated, Huckel's rule of 4n plus 2 pi. The hybridization of carbon in benzene is sp2 hybridized, bond angle is 120 degree and it is planar. Note down, students.
Noted, sir.
Now let us see few other aromatic compound. Like if you have a benzene ring, this can be written like this also. If methyl group is added, then it is called methyl benzene, also called toluene. Methyl benzene or toluene. Suppose if you have a benzene ring with chlorine attached to it, then it is called chlorobenzene. Suppose you have a benzene ring with bromine attached to it, then it is also called bromobenzene. Suppose you have fluorine attached to benzene ring, then it is called fluorobenzene. Suppose if you have two benzene rings fused together, then it is called naphthalene. Now, if you have three benzene rings fused together, then it is called anthracene. Suppose if you have a benzene ring with two methyl group, then you name it like this: 1,2 dimethylbenzene. If you have a benzene ring with OH group, then it is called phenol. Keep in mind that the 1,2-dimethylbenzene commonly is called orthoxylene. So dimethylbenzene are also called xylenes. So there are three types of xylene: orthoxylene, metaxylene, and paraxylene.
Copied, sir.
If you have a benzene ring with NH2 group, then it is called aniline. If you have a benzene ring with 2 OH group, then you have to write complete benzene first, then position 1, 2, and then diol. Di means 2, ol means alcohol. If you have Cl and OH attached, then you have to give priority to OH, so it will become 2-chlorophenol. Commonly, it is also called orthochlorophenol. Suppose you have a benzene ring with COOH group attached, then it is called benzoic acid. It is also called benzene carboxylic acid. Both are recommended UPAC name, benzene carboxylic acid. If you have a benzene ring with CHO, then it is called benzaldehyde. It is also called benzene carbaldehyde. If you have a benzene with CN group cyanide, then it is called benzonitrile. If you have a benzene ring with CONH2, then it is called benzamide. If you have a benzene ring with COCH3, it is called acetophenone. Acetophenone. If you have a benzene ring with SO3H, it is called benzene sulfonic acid. If you have a benzene ring with NO2 attached to it, it is called nitrobenzene.
Noted, sir.
Suppose you have a benzene ring with N2Cl. This is called benzene diazonium chloride. It is a salt. By benzene diazonium chloride, it is called diazonium salt. So it is a salt. If you have a benzene ring with 2 nitro groups, then it is called 1,3-dinitrobenzene. If you have a benzene ring with methoxy group OCH3, then it is also called methoxybenzene or anisole. Anisole. If you have a benzene ring with NH2 and bromine group attached opposite to each other, it is called 4-bromoaniline. Aniline is also called benzenamine.
Noted.
Structure of benzene. Benzene C6H6 has high degree of unsaturation. Keep in mind that the degree of unsaturation of benzene is 4. How to know degree of unsaturation? Keep in mind that degree of unsaturation is equal to number of rings plus number of pi bonds. So in benzene, the number of ring is 1 and number of pi bond is 3. So the degree of unsaturation of benzene is 4. Keep this in mind. Despite high degree of unsaturation, it resists addition reaction. Why it resists addition reaction? Because when it undergo addition reaction, it loses its aromatic stability. So it loses its aromatic stability. So it prefers electrophilic substitution reaction. Electrophilic substitution reaction. Note down.
Noted, sir.
So the benzene carbon, any of the benzene carbon is sp2 hybridized. It is 120 degree. It is planar. Carbon-carbon bond length in benzene is 1.39 angstrom, and it was experimentally proved by X-ray crystallography, etc., X-ray diffraction techniques. So benzene was isolated by Michael Faraday in 1825. Now keep in mind that the pi electron in benzene keeps on moving. So this is called resonance. This is called resonance. This is called the resonance hybrid, which is more stable than either of the other forms.
Noted, sir.
So in resonance, what happens? This pi bond keeps on oscillating. This goes here, this goes here, this goes. So this is actually resonating structure, and it is called resonance hybrid. Now keep in mind that now look at this 1,2-dibromobenzene. If you will find interesting thing here, the bromine is attached to the carbon, which has a double bond. But here bromine is attached to a carbon which don't have double bond. But there is no difference between these two compounds, and that is due to resonance. That is due to, so write down no difference. Because the pi electron keeps on moving, so it's like, so it is called delocalization of pi electron. Of pi electrons.
Copied, sir.
If you want to see the orbital picture of benzene, then look at like this. You will better understand this. This overlap with this. This way it overlaps. The bottom one overlaps or like this. This way it overlaps. So suppose the ring becomes like this. Then here the aromatic character is lost because it becomes sp3. So it will not be aromatic.
Copied, sir.
Now we will discuss another concept that is called aromaticity. So benzene is considered as the parent aromatic compounds. Now this is applied to all the systems which have rings like benzene or may not have rings like benzene, but they possess planarity. So first concept is planarity. It must be planar. Second is there will be a complete delocalization of the pi electrons in the ring. And third is presence of 4n plus 2 pi electrons in the ring where n is an integer, n is equal to 0, 1, 2. So this is often referred as Huckel's rule. Huckel rule. So you remember my trick, that will be more better, students. The trick goes like this: CPCA, cyclic planar conjugated Huckel's rule of 4n plus 2 pi electron. So if you remember this simple trick CPCH, you will be able to solve a lot of questions. Which is aromatic, which is not aromatic, and what is the reason for being not aromatic. Note down.
Noted, sir.
Now we will see few examples based on this. Suppose we have this molecule. Now this. So if you see it is cyclic, yes, it is cyclic. It is planar, yes, it is planar. It is conjugated, yes, it is conjugated. Here sigma, this pi bond will also be part of conjugation. Will it follow Huckel's rule? Yes, it will follow, because 2 pi electron, 4 and 6. So it has 6 pi electron. 6 pi electron means 4n plus 2 pi electron. If you take n equal to 1, so you will get 4 into 1 plus 2 pi electrons. So it will be 6 pi electrons. Since it is matching with this, so it is aromatic in nature. So write down aromatic. The name of this compound is cyclopentadienyl anion. So the name of this compound is cyclopentadienyl anion.
Noted, sir.
Next compound I want to show you. So if you see here, it has how many carbon? 1, 2, 3, 4, 5, 6, 7. 7 means it is heptagon. Okay. Now, here is a double bond, here is a double bond, and here is a double bond. But there are no double bond over here. So it becomes non-aromatic. It becomes non-aromatic. Why it will become non-aromatic? Because here the carbon hybridization is sp3. The resonance is there till here, but after that it breaks. So it becomes a non-aromatic compound. But if you see this compound properly, look at this compound 1, 2, 3, 4, 5, 6, 7. So if you have this compound and here is a plus charge is there, this is called cycloheptatrinyl cation. Cycloheptatrinyl cation, then it is aromatic. Why it is aromatic? Because it is cyclic, yes. It is planar, yes, because this carbon is also sp2 now. Is it conjugated? Yes, it is conjugated. Will it follow Huckel's rule? Yes, it will obey Huckel's rule because it has 6 pi electrons. So this makes cycloheptatrinyl cation as aromatic. Understood?
Yes, sir.
Now we will see another molecule like fourth. Will cyclopropene be aromatic? Will cyclopropenyl cation be aromatic? Will cyclobutadiene be aromatic? So see, here the carbon is not sp2, so it is sp3, so it is non-aromatic. Now here the carbon is sp2 hybridized and it has 2 pi electron. 2 pi electron will fall in this formula, 4n plus 2 pi electron. So if you take n equal to 0, it will become 2 pi electrons. So it is aromatic because it is cyclic, it is planar, it is conjugated, it is following Huckel's rule. So all this property it follows. So cyclopropenyl cation is aromatic. Understood?
How do we identify its hybridization for aromatic and non-aromatic?
All the carbons are single bond, then single bond all through, then it is sp3. If it is a
Okay,
double
so
bond,
sp2.
sp2. If it is a triple bond, then sp. If carbon has a plus charge, then sp2. If carbon has a minus charge, then sp3. Okay.
Yes, sir.
So here is a plus charge, that's why it is sp2. No problem up till now.
No problem, sir.
But here you see an interesting phenomenon. Cyclic, yes it is. Planar, yes it is. Conjugated, yes it is. But it will not obey Huckel's rule, but it will obey Huckel's rule of 4n pi electron rule. If n equal to 1, you take 4n pi electron rules. If you take n equal to 1, it will become 4 pi electrons. See, it is 4 pi. This is 2 pi, this is 2 pi. So 4 pi electrons are there. So it is called anti-aromatic compound. So cyclobutadiene is an anti-aromatic compound. It is cyclic, planar, conjugated, but it will not obey Huckel's rule of 4n plus 2 pi, but it will obey Huckel's rule of 4n pi electron. So this is called anti-aromatic. They are the most unstable compound.
Noted, sir.
Now coming to naphthalene. If you see naphthalene, if you see naphthalene, it is cyclic, yes, it is cyclic. It is planar, yes, it is planar. It is conjugated, yes, it is conjugated. Will it okay Huckel's rule? So yes,
No.
4n plus 2 pi electron. So just take n equal to 2 here. So 4 into 2 plus 2. That means it has 10 pi electron. If you measure, if you count, then it is 2 pi electron, 4 pi electron, 6 pi electron, 8 pi electron, 10 pi. That means it is naphthalene is aromatic. Write down. Will it be aromatic? It is called cyclopentadiene. Is it aromatic?
Yes, because it has 4 pi electrons in it.
It has 4 pi electrons, so it will be not aromatic. And here is it sp3 hybridization, so it is non-aromatic compound. Write down. But if you have like this structure, here a positive charge, then it becomes anti-aromatic compound. It is called cyclopentadienyl cation because it has now 4 pi electron. Okay, 4 pi electron, and it is planar. So here planarity is lost. Okay, here planarity is lost, and here sp2 becomes sp3. Okay, so cyclopentadienyl is non-aromatic, but cyclopentadienyl cation is anti-aromatic. Understood?
Yes, sir.
Note down.
Noted, sir.
Now, if you see this compound, is it aromatic, anti-aromatic, or non-aromatic? So it is cyclic, yes. It is planar, no. Planarity is lost here because it is sp3. Conjugated, double bond, single bond, double bond, but single bond, single bond. So not.
Non-aromatic.
So it is non-aromatic. Very good. Note down. There are 6 pi electron, but this 6 pi electron is not part of the ring, but it is outside the ring.
Noted, sir.
Now write down methods of preparation of benzene. Methods of preparation of benzene. So first is cyclic polymerization of ethyne. Cyclic polymerization of ethyne. As you know, CH, triple bond CH, it is ethyne. If you take red hot iron tube at 873 Kelvin, it forms benzene. So this is actually an example of trimerization reaction because 3 moles of acetylene react in presence of red hot iron tube to form benzene. It is the conversion from aliphatic to aromatic. Aliphatic to aromatic. In alkyne, the hybridization of carbon is sp, but in benzene it is sp2. Understood?
Yes, sir.
So this is cyclic polymerization of ethene, very important reaction. Next method of preparation is from phenol. From phenol. If you take phenol, treat it with zinc dust and heat it, it will form benzene. The zinc will take away oxygen to form ZNO.
Noted, sir. Then what will happen to the hydrogen here, sir?
Which hydrogen?
In this OH.
Oh, in place of OH, no, O will only go with zinc. H will remain there to form benzene.
Okay, sir.
Because phenol is C6H5OH. So O will go, then it will become C6H6. Third is decarboxylation of aromatic acids. So if you take aromatic acid and do decarboxylation reaction with soda lime, like if you have sodium benzoate, which is used as a food preservative, sodium benzoate treated with it forms benzene plus sodium carbonate. In this reaction, CO2 is lost, so that is called decarboxylation, loss of CO2 from aromatic acid. This sodium benzoate is also used as food preservative, so you can keep this in mind. It is used as a food preservative also. Fourth method is by treating benzene diazonium chloride with ethanol. So if you take benzene diazonium chloride, this is benzene diazonium chloride, treated with ethanol, it will form benzene plus ethyl alcohol. Plus nitrogen gas plus HCl. So this reaction also forms benzene. Copied?
Yes, sir.
Next is physical properties. Physical properties. Aromatic hydrocarbons are non-polar molecules. That means their dipole moment is 0. They are usually colorless liquids or solids with a characteristic aroma. Aroma means smell or fragrance. So they are usually colorless liquids or solids with a characteristic aroma. They are non-polar molecule. Naphthalene balls are used in toilets and for preservation of cloths because of unique smell of the compound. And moth repellent property. So it repel moths also. It has a very good smell. It preserves cloths and it is also used in toilets. These are insoluble in water, so they will not dissolve in water. But or readily miscible in organic solvent. So they are highly soluble in organic solvent with a concept like dissolves like. With the concept like dissolves like. This question was asked in IIT. They burn with sooty flame. This is IIT question. They burn with sooty flame. So this was IIT question, and they asked in IIT Advanced. So these are the physical properties of aromatic hydrocarbons.
Noted, sir.
Now we are going to discuss chemical properties of aromatic compound. Chemical properties. So the unique property of benzene is that it acts as a nucleophile. So benzene is actually an electron-rich system. So electron-rich systems are also called as nucleophile. So benzene is a nucleophile. So what happens? It reacts with an electrophile to form the substituted product. To form the substituted product with the release of H+. So it undergo, this is called electrophilic substitution reaction. Electrophilic substitution reaction. Very important reaction. So let me discuss electrophilic substitution reaction in detail. Types of electrophilic substitution reaction. 4 types. Halogenation. Second is nitration. Third is sulfonation. Fourth is Friedel-Crafts reaction. So we will be discussing the details of electrophilic substitution reaction. Halogenation means addition of halogen. Nitration means addition of NO2+. Sulfonation means acetylene of sulfur trioxide. Friedel-Crafts reaction is further of 2 types. Friedel-Crafts alkylation. Friedel-Crafts acylation.
Yes, sir.
Now let me discuss Friedel-Crafts. Let me discuss halogenation. Start with halogenation. So halogenation means addition of halogen. Addition of halogens. So you take benzene, treat it with chlorine in presence of anhydrous AlCl3. This will form chlorobenzene. This will form chlorobenzene as well as HCl. So what happens? AlCl3 catalyst react with chlorine to form AlCl4 minus plus chloronium ion. So this is the electrophile. So the electrophile during this reaction is chloronium ion. This is called chloronium ion. Chloronium ion. So this only helps. So this only attacks the benzene ring. So chloronium ion attacks the benzene ring to form chlorobenzene. So the effective electrophile is chloronium ion. Understood?
Yes, sir.
If you take bromine, treat it with benzene in presence of FeBr3, then also it forms bromobenzene plus HBr. So note down.
Noted, sir.
Second reaction is nitration. Nitration, the nitrating mixture, nitric acid and concentrated H2SO4 react. So it forms H2NO2 NO3 plus HSO4. This forms H2O plus NO2 plus. So this is the effective electrophile. Keep in mind that nitric acid acts as base here, sulfuric acid acts as acid. So this was asked in IIT. So during nitration, nitric acid acts as base. So this is the electrophile. This is the effective electrophile which is generated during the reaction. So when we carry out nitration of benzene, so it forms nitrobenzene plus water. So this reaction generally takes place at 323 to 333 Kelvin. So benzene forms nitrobenzene.
Noted, sir.
Third is sulfonation. In sulfonation, benzene reacts with fuming sulfuric acid. Fuming sulfuric acid is H2SO4 mixed with SO3. So it is also called oleum. Oleum is H2H2O7. So the sulfonic group get attached to the benzene ring. So this becomes benzene sulfonic acid. Benzene sulfonic acid.
Noted, sir.
Fourth reaction we are going to discuss is Friedel-Crafts reaction. Friedel-Crafts reaction. So there are two types of Friedel-Crafts reaction. One is Friedel-Crafts acylation, another is Friedel-Crafts alkylation and acylation. So first we are going to discuss alkylation. So A is Friedel-Crafts alkylation. So we take benzene, treat it with methyl chloride in presence of anhydrous AlCl3. So it forms toluene. It forms toluene. A methyl group get introduced plus HCl is the byproduct. So how this reaction happens? Methyl chloride reacts with AlCl3 to form AlCl4 plus AlCl4 minus plus methyl carbocation. This methyl carbocation is the electrophile. So methyl benzene is also called toluene.
Yes, sir.
Next is Friedel-Crafts acylation. We take benzene, treat it with ethynyl chloride in presence of Lewis acid catalyst and anhydrous AlCl3. It forms acetophenone. It forms acetophenone plus HCl. So what happens? This ethynyl chloride react with AlCl3. So it forms acetyl carbocation plus AlCl4 minus. This attacks the benzene. This is the electrophile.
Noted, sir.
Even if you treat benzene with acetic anhydride in presence of anhydrous AlCl3, it forms acetophenone. It forms acetophenone, also called methyl phenyl ketone plus acetic acid. This is called acetophenone. This is acetic acid, also called ethanoic acid. If you take excess of reagent, further substitution will take place and all the hydrogen atom of benzene ring may be successfully replaced by electrophile. So let me give you one example. So if you have benzene and you are treating with excess of chlorine in presence of anhydrous AlCl3 in dark and cold condition, so it will form hexachlorobenzene. It forms hexachlorobenzene. So this is C6Cl6. All the hydrogen has been replaced by chlorine. So it is called hexachlorobenzene.
Noted, sir.
Now we will see the mechanism of electrophilic substitution reaction. Mechanism of electrophilic substitution reaction. It is also written as SE. SE means substitution electrophilic. Substitution electrophilic. First is generation of the electrophile. First step is the generation of the electrophile. Second step is the formation of carbocation intermediate. Formation of carbocation intermediate. And third is removal of proton, that is deprotonation, removal of proton from the carbocation intermediate. So this way the mechanism happens. So let me discuss one of the mechanism. Copied.
Copied, sir.
So let me discuss. So first step is generation of electrophile. Generation of the electrophile. This I have already discussed, but again I will revisit. Suppose CCl bond is there. If you treat it with AlCl3, so this will become chloronium ion plus AlCl4 minus. This is the electrophile that is generated. Similarly, if you have CH3Cl plus AlCl3, this will shift, this will go and attack. So it will form methyl carbocation plus AlCl4 minus. So this is the electrophile. So this way the electrophiles are generated.
Noted, sir.
Now let me see the formation of carbocation. Formation of carbocation. So what happens? Benzene is there and an electrophile is there. I am taking a general mechanism. So this attacks. Now what happens? This pi bond shifts to the electrophile. So I'm showing the hydrogen. So if it shifts, a positive charge comes. So this becomes a sigma complex. It becomes a sigma complex. Sigma complex is also called arenium ion. Arenium ion. Now what happens? These arenium ion get stabilized by resonance. These arenium ions get stabilized by resonance. So let me show you that step. This shift here, pi bond comes here, but here is the positive charge that goes. Now, this will shift here. This will generate a pi bond over here, then it will generate a carbon here. This way it keeps on doing and ultimately forming resonance like this. Now, ultimately, sigma complex or aluminum ion loses its aromatic character because one of the carbon is sp2 here. So this carbon is actually sp3 here, sorry. So here it loses its aromatic character. So now the third step, there will be a removal of proton. Removal of proton. So how it happens, I will show you. So you see, so here is the proton, here is the electrophile, here is the hydrogen. So now AlCl4 minus comes. This gives the electron to proton and this gives this electron here. Once it gives the electron here, a pi bond will come here. Its aromatic character is restored. And here is the electrophile. Now this H plus will take away the chlorine to form HCl, and AlCl3, which was acting as catalyst, will come out as AlCl3. So this way the mechanism happens and the substituted product is formed.
Yes, sir.
Now some other reaction, we are going to see some addition reaction. So under vigorous condition, benzene do undergo addition reaction and lose its aromatic stability. So take benzene, treat it with hydrogen in presence of nickel hydrogen. In presence of nickel heat, it will form cyclohexane. So from aromatic, it becomes aliphatic. So at high pressure, high temperature, benzene react with hydrogen in presence of nickel catalyst to form cyclohexane. This reaction is an example of hydrogenation, and it is presence of catalyst, so it is called catalytic hydrogenation. So it is an example of catalytic hydrogenation. Note down. Understood?
Yes, sir.
Under ultraviolet light, 3 chlorine molecules add to benzene. add to benzene to produce benzene hexachloride. Benzene hexachloride and hexachlorobenzene both are different. Keep in mind. Benzene hexachloride is C6H6Cl6, also called gamexine, which is used as insecticide. Gamexine or lindane or 666. There are so many names. Its name is lindane. Its
Yes,
name
sir.
is 666. Okay. So
Yes,
take
sir.
benzene, treat it with 3 moles of chlorine in presence of UV at 500 Kelvin. All the double bond breaks and all position chlorine comes along with hydrogen. Hydrogen is also there. Don't think, because carbon cannot have 3 valency. So hydrogen is also there. So C6H6Cl6, that's why it is called 666 lindane gamexine or benzene hexachloride. This is used as insecticide. Okay. So this has been asked in IIT. 666 lindane gamexine benzene hexachloride C6H6Cl6.
Yes, sir.
Now combustion reaction, when we burn an organic compound in presence of oxygen or air. So combustion reaction, benzene react with 15/2 O2, that is 7.2 moles of oxygen to form 6 moles of carbon dioxide plus 3 moles of water. We're releasing huge amount of energy. Okay, so it burns with sooty flame. Burns with sooty flame. So this has been asked in IIT. So this is very, very important. So this is the combustion reaction of benzene. If you want to know the general reaction for combustion, you have to just remember this. CXHY plus X plus Y by 4 O2 give X CO2 plus Y by 2 H2O. So if you remember this general formula, you don't need to balance. You just have to see 6 by 4, that 3 by 2. So if you will calculate, you will get 15 by 2. And X is 6, so it is 6. Y is 6. 6 by 2 is 3. Understood?
Yes, sir.
Note down.
Noted, sir.
This was all the chemical properties of benzene. Now we will see, suppose you have a benzene ring excuse me, with a group attached. Now this group, if it is activator, means if it increases electron density in benzene ring, then it will be ortho para directing group. Ortho and para directing group. Like, what are the ortho para directing group? I'm giving you these are activating group, like NH2 group, NHR group, NHCOCH3 group, methoxy group, methyl group, ethyl group, hydroxide group, NH2 group. These are all, NH2 already have been written, so not want to repeat it. So these are all ortho para directing group. They are also called plus R group or plus M group. So due to this group, new position occupied is ortho para, not meta. Okay, so any group which increases the electron density in the benzene ring are called activator. They are ortho para directing group. Suppose if you have, suppose methoxy group, and you are doing, suppose, chlorination in presence of anhydrous AlCl3. So what will happen? A chlorine group will come at ortho and para position. So here will be a chlorine coming, and here will be a chlorine coming. So due to this group only, the new chlorine is coming at ortho position and para position. This will be the major product. This will be the minor product, because here some steric hindrance will be there. So a group which increases the electron density in benzene is called an activator, and activators are ortho para directing groups. And when such a group are treated, undergo electrophilic surgery, they bring the groups at ortho and para, with para being the major, ortho being the minor. This is called directive influence of the functional group or groups present in mono-substituted benzene.
Yes, sir.
Keep in mind that chlorine, bromine, iodine, they are slightly deactivating, but still they are still ortho-para-directing group. Still ortho and para-directing. So slightly they pull the electron through inductive effect, but still they are ortho-para-directing group. So even in presence of chlorine, if you do chlorobenzene, if you do methylation, CH3Cl, anhydrous AlCl3, then what will happen? A methyl group will come at ortho and para position. Understood?
Yes, sir.
Note down. Copied?
Noted. Yes, sir.
Now we will see there are certain groups like nitro group or any group which withdraws the electron. So they are called deactivating group, deactivator. So generally the deactivator group are meta-directing group. So they direct the incoming group at meta position. So keep this in mind. I am giving you the list of the groups which are meta-directing. So like the nitro group, the CN group, the aldehyde group, the ketonic group, the carboxylic acid group, the ester group, sulfonic acid group, or NH3 plus group, or CCl3 group, CF3 group. These are all meta-directing groups. So they direct the incoming group at meta position. They direct the incoming group at meta position. So if you remember this, these are all called -R or -M group. So they, like if you have nitrobenzene, suppose nitrobenzene, and you are carrying out nitration, suppose nitration you are carrying out. So the new group will come at meta position. So nitration of nitrobenzene will generate 1,3-dinitrobenzene. So meta position nitro group will come. Note down.
Noted.
Suppose if you have benzaldehyde, CHO, this is also a deactivator group and this is also a meta-direct. Suppose you carry nitration, then nitro group will come at meta position. So this will become 3-nitrobenzaldehyde. Suppose if you have benzoic acid, and you carry out nitration, then nitro group will come at meta position. So this is, if you remember only the group, if you remember only this group, then this group will decide the position. So this group will decide the position, meta position. So this was directive influence of functional group in mono-substituted benzene.
Yes, sir.
Now, last topic, we are concluding the chapter with carcinogenicity and toxicity. So carcinogen means cancer causing. Carcinogen means cancer causing. Mutagenic means mutation causing. Mutation is sudden heritable changes in the genetic material. So there are almost 200 different types of cancer. 200 different types of cancer. Types of cancers are there. The study of cancer is called oncology. Study of cancer is called oncology.
Yes,
So
sir.
now as the number of cancer cases are increasing in the world, so people are just trying to find out what is the main cause of this cancer. So they have come up with like polynuclear aromatic compound. So benzene, some polynuclear aromatic compound. Polynuclear means having more than one benzene ring. Polynuclear hydrocarbons. So what happens if they have more than two benzene rings? They are toxic. They are toxic and they have carcinogenic property. They have carcinogenic property means cancer causing genic properties are there. So how and why I will explain you. Note down. Copied.
Yes, sir.
Now when you like, if suppose tobacco is there, coal is there, petroleum is there, if they undergo incomplete combustion, then they generate polynuclear hydrocarbon. They form polynuclear hydrocarbons. These polynuclear hydrocarbons, which are formed due to incomplete combustion of tobacco, petrol, coal, etc., they enter human body. And in the human body, what happens? They undergo various biochemical change, biochemical reaction. And finally, what happened? They damage the DNA. They damage our blueprint of life, that is damaged DNA. And this damaged DNA finally lead to cancer. So some of these carcinogenic hydrocarbon I will be drawing in just a few minutes. So what happens due to tobacco, coal, petroleum, when they undergo incomplete combustion, they generate polynuclear hydrocarbons. They enter human body. They undergo certain biochemical reaction. Ultimately, they damage the DNA, which leads to cancer. There are so many different types of cancer, as I have already told you. So this is the major cause. The main cause of these cancers are polynuclear hydrocarbons, which are produced by the incomplete combustion of coal, petroleum, and tobacco.
Yes, sir.
Now, few of the structure of this polynuclear hydrocarbon I'm drawing, and I will conclude the chapter. This is called 1,2-bench anthracene. So they are polynuclear hydrocarbon. Another example is, there are a lot of other examples also, but I will be restricting with 2 only. They will not ask you this much, but they can ask you that these polynuclear hydrocarbons do cause cancer. So this compound is called 9,10-dimethyl 1,2-bench anthracene. So these are the polynuclear hydrocarbons which are responsible for cancer, responsible for various types of cancer. Understood? So this was the chapter, student. I hope you understood. Thanks for watching. This is Sandeep sir signing off.